Today, we're going to pull back the curtain on maybe the single most important piece of software on any device you own, the operating system. It really is the unseen hero, the silent conductor of our entire digital lives. I mean, have you ever really stopped to think about it? You tap an icon, you click a button, and 1,000 different things just happen in the blink of an eye. A document gets saved, a video starts to play, a message zips across the world. How does your computer actually do all of that? Well, it's not exactly magic, but it's pretty darn close. It is the operating system, the OS, and it's working tirelessly in the background, managing every single little detail so you don't have to. All right, let's dive in. To really get a handle on this, you gotta think of the OS as the central intelligence of your device. It's kind of like the ghost in the machine that brings all that lifeless hardware to life. So what is it really? At its core, an operating system is the fundamental software that acts as the middleman. It's the translator between you, the user, and all the physical computer hardware. We're talking the chips, the memory, the screen. It takes your clicks and taps and turns them into a language the hardware can actually understand and act on. Probably the best way to think about the OS is to imagine it's the CEO of your device. I mean, it has this massive company to run, and it's got to juggle 4 incredibly important jobs to make sure everything runs like a well-oiled machine. And these are its 4 core functions: process management, user interface, resource management, and security. You can actually remember them with the acronym PERS. Think of it like this: process and resource management, that's the OS handling all the internal logistics, right? The user interface, well, that's how it shows everything to you on the screen. Your windows, your icons, all of it. And security, that's its role as a bodyguard, protecting all your data. Let's start with those internal logistics first. So first up is process management. I want you to picture a chaotic intersection with hundreds of cars all trying to get through at once. Total gridlock, right? The OS is the traffic cop for your computer's brain, its processor, or CPU. It's the one deciding which task gets to go next, for how long it gets to go, and making absolutely sure there are no crashes. Now, here's a really crucial distinction. We talk about programs all the time, like our web browser or a game. But to an OS, that program is just a static, lifeless file. It's only when you launch it that it becomes a living, breathing process, a dynamic task that is actively using up memory and CPU time. And this is what the OS is truly managing, not the app sitting on your desktop, but the countless active processes they create. And then there's resource management. See, your computer has a finite amount of stuff. A certain amount of memory or RAM, a specific number of processor cores, and devices like your keyboard or your printer. The OS is the master allocator, making sure every single running process gets its fair share of these resources without letting another one starve. But man, it was not always this sophisticated. To really appreciate the OS you're using right now, you have to see where it all came from. So let's take a look at a quick origin story. Way back in the earliest days of computing, there was no OS. None. Programmers had to literally manually load programs one at a time. Then came simple batch systems, which could at least run a stack of jobs one after the other. That evolved into multi-program systems that could juggle a few programs at once. And that eventually led us to today's amazing time-sharing systems, where the OS switches between tasks so insanely fast, it feels like everything is happening all at once. And this just perfectly illustrates the difference, doesn't it? We went from a world where one person manually fed one program at a time, to a machine that was just sitting idle most of the time, to today where multiple users can run countless programs interactively, and the CPU is never, ever wasting a single cycle. The leap forward is just staggering. Okay, so we've established the OS is a master scheduler and a resource manager. Now let's zoom in on 2 of its most relatable jobs: how it acts as the ultimate organizer for both your files and your computer's memory. Every single time you save a photo or a document or a game, the OS's file system takes over. It's like a master librarian for your hard drive. And it doesn't just throw a book on a random shelf. It knows exactly where every single piece of data is located, how it's all organized, and how to retrieve it for you instantly. And just like libraries, file systems have evolved. Older systems like FAT were really simple, but also fragile, with basically no security to speak of. Modern systems like NFTs, which is used in Windows, are incredibly robust. They can automatically recover from errors, and they support file-level encryption and permissions, which keeps your data much, much safer. The OS also kind of acts like a janitor for your hard drive. Over time, a file's data can get scattered into little pieces all over the physical disk. This is what we call fragmentation. The OS can run a defragmentation process, which is basically it tidying everything up by putting all the pieces of each file back together in one continuous block. And doing that makes accessing them way, way faster. But maybe the most mind-bending trick the OS performs is memory management. Seriously, imagine a magician with a tiny little desk who can somehow juggle dozens of huge objects all at once. That's your OS, but with its very limited physical RAM. So how in the world does it pull off this magic trick? Well, it uses a technique called virtual memory. It's so clever. The OS uses a portion of your much slower but much larger hard drive as if it were an extension of your super fast RAM. It's constantly swapping pieces of programs in and out of that real RAM as they're needed, which creates this amazing illusion that you have an almost infinite amount of memory. This is exactly how you can run massive applications on a machine with just a few gigabytes of actual physical RAM. It's incredible. So, when you put all these pieces together, the process manager, the resource allocator, the file librarian, the memory magician, you start to realize the OS isn't just a piece of software. It's your personal digital butler. At the end of the day, it's the reason you can edit a video while listening to music and getting email notifications all at the same time. It finds your files in a split second, it connects to your printer without a fuss, it protects your data by asking for a password. It does all of the hard work just to give you that smooth, seamless experience. So the next time you power on your phone or your computer, just take a second to appreciate the silent, brilliant work of its operating system. Which it does leave us with one final thought. As our devices become smarter and more connected to the world through things like AI, what new, incredible responsibilities are we to give to this digital butler? What's the next big job?